Okay, we're going to graph a cosine function, 3 cosine of 2x plus pi minus 1. And we're going to do that over a 2-period interval. But before I actually graph this function, let's just, for practice, identify the important parts of our cosine wave. That 3, which is in front of our cosine, if we take the absolute value of that 3, that will give us 3, and that is going to give us the amplitude of our wave. Okay? Now, the period is going to be what? Well, we're going to take 2 pi, which is the period of our parent function. Okay, so the parent function would be the very original cosine function. And if you have a 2 in front of that x, then that means that the parent function was horizontally stretched by a factor of 1 over 2. Okay? So that's now going to give us a period of 1 pi. Okay? Now, we also have a horizontal shift, or what we also call the phase shift. Now, to identify what the phase shift is, or the horizontal shift, you have to figure out what number is being added or subtracted from just the x alone. So that means that you would have to take that expression, 2x plus pi, and then you would have to factor out the 2. So if I factor out the 2, I get x plus pi over 2. Okay? So now the number that is being added to my x is pi over 2. Okay, so what I have is a horizontal shift, or what we call the phase shift, and that's going to be pi over 2 units to the left, okay? Because we are adding from that x inside. And then lastly, we have this minus 1, which means that we have a vertical shift. And so we are subtracting 1, so that means that the vertical shift is down 1 unit. Okay? So that 3 in front gave us our amplitude, but remember that meant that the original parent function was stretched vertically by a factor of 3. Okay? So now let's go ahead and graph this cosine wave. Okay, so step number 1, remember we're going to find what I called in class the starting interval. So I'm going to take that 2x plus pi, and I'm now going to place it in between 0 to 2 pi. And I'm choosing 0 to 2 pi because that is the starting interval for the parent function, the regular cosine. And we want to see how the phase shift and the horizontal stretch are going to affect this interval here. So all we have to do is solve for x. We subtract pi from all sides. And then I'm going to divide by 2. Okay. So that interval is the interval that I'm going to use to begin graphing this function here. Notice the length of this interval. So I think you would agree that 0 is in the middle. So from the 0 in the middle, you would go out pi over 2 units to get to this endpoint. Then you would go another distance of pi over 2 to get to that left endpoint. So that means that this interval here has a full length of 1 pi. And that 1 pi is the period that we had identified earlier above. Okay, so now I'm going to draw my x-axis. Okay, and I will pick this interval here to start, and that left endpoint will be at negative pi over 2. The right endpoint is pi over 2. Okay, so I'm placing this interval here on my number line. Now, I'm going to divide that number line up into 4 equal parts. So 0 is the average between those endpoints, and then there's another intermediate value here, and another intermediate value there. Okay, I think that you would agree that if we wanted to go find them, that would be pi over 4, and that would be negative pi over 4. Okay, now what I'm going to do is I'm going to place my ruler here at the left endpoint. You could put it at 0 if you like. I always put mine at the left endpoint. And now I'm going to draw my y-axis. Okay, there's the x-axis and now the y. And we need to figure out what is the range. What is the range for this cosine function? Well, the parent function, the original cosine, has a maximum of 1, middle of 0, and a minimum of negative 1. But when we multiplied by 3, we had a vertical stretch, so now the maximum became 3, the middle stayed at 0, and the minimum became negative 3. But then we see that we had a vertical shift, and all of these points were moved down 1 unit. So now the maximum falls down to 2, the middle goes down to negative 1, and the minimum goes down to negative 4. Okay, so here. There's 1, and here's 2. Let me erase this here. 1, negative 2, negative 3, and negative 4. Okay, so my y values, okay, my range for this function will go between negative 4 and 2. All right, now let's put back what we had before. This was the left endpoint of negative pi over 2. Okay, now the cosine wave is going to start at its maximum. Okay, notice that there was no reflection. So at negative pi over 2, I'm going to start now at the maximum value, which is 2. And then at this next value, which is negative pi over 4, the cosine function is going to take on its middle value, which is here at negative 1. Okay, so the cosine wave, the cosine function is going to decrease from maximum to middle, then it's going to continue decreasing down to the minimum. So that would be at 0. Okay, so it continues to decrease down to 0. And then at this intermediate value of pi over 4, it comes back to the middle, which was negative 1. Okay, so now the function is increasing. And then at pi over 2, it increases back to the maximum. Okay? So we have graphed our cosine wave over one full period. Okay? Remember, from negative pi over 2 to pi over 2, the function took on one full period. Okay? Now we're going to graph it over the second period interval. So you can extend to the right or extend to the left. I'm going to extend left. So what I'm going to do is I'm going to take negative pi over 2, which is this left endpoint, and then I'm going to subtract the period, which is pi, to go left. Okay? So, if I take the left endpoint of negative pi over 2, and then now I subtract the period, which is pi, well, pi is the same as 2 pi over 2. That's going to give us a left endpoint of negative 3 pi over 2, right? Negative 1 minus negative 1 pi minus 2 pi is negative 3 pi over the 2. Okay? And so this next interval needs to be the same length as the first. Okay? So you can do it more accurately with a ruler. Okay? So on the exams class, I'm going to require that you label that endpoint, okay? Just the endpoint of the second interval. And now we're going to cut this into 4 equal parts. Okay? And now we're going to replicate that cosine graph now over this interval. So on the left endpoint, I'm going to start at the maximum, same as what I did over here. Okay? And then at the second value here, this intermediate value, I'm going to decrease down to the middle. Okay? And then I'm going to decrease to the minimum, which was here. Okay, and then increase back to the middle. And then increase back to the max. Okay, so that red portion of my graph is just this black curve here replicated to the left. Okay, and of course this function has a domain which is all real numbers, so we want to indicate that this wave just continues endlessly to the left, and then of course that arrow indicates that it's going to continue endlessly to the right. Okay, so just a couple of highlights before we end this video. The amplitude, which was 3, is going to be the height of that wave, so I can highlight that for you. That would be this distance here. Okay, so the amplitude is the distance from the maximum value to the middle. Okay, so that is a distance of 3 units. Okay, so that's my amplitude. And of course the period was the length of this interval here. Okay, so this was my period, which was pi. And that is the same as this length here. Okay? So on that full period, the function is going through one full cycle. It goes from maximum to middle to min, back to middle, and then returns back to the maximum where we said it started. Okay, and the same is true on that black portion right there of the curve. All right, I hope that helps.